Hello, so today we'll be doing this minimum number of steps to make two strings anagram. So we have two equal strings, S and T. In one step, we can choose any character of T and then replace it with another character. And we want to return the minimum number of steps to make the second string an anagram of the first one. So an anagram is basically just a string that contains the same characters, maybe in different orderings than the first one, right? So we have this one, and if BAB, if we replace the first A with, in T here, if we replace the first A with B, we get this, which is an anagram of BAB. They have the same characters and the same number of occurrences. So, and similar thing for Leetcode. So here we need to return the number of characters that we need to replace. For Leetcode, we need to replace 5 characters, because if you look here, you can see E is already there and T is already there. The rest of the characters are different, so we need 5 at least. Okay, so how can this be done? So the first thing that we did here when we were trying to just do this manually is look at the characters that already occur in one and the other. So what I'm thinking is maybe a map of occurrences for both. So we would have a map for S and the map for occurrences of T. And once we find those two maps, we can take the difference, right? So let's say if we have the map for both. So if you have the map, let's say for, let's take this Leetcode, which is a little bit harder. So we have L, we have one of them, E, we have 2. And for C, we have, for C, we have 1. For O, we have 1. And then for D, we have 1. And then for E, actually, we have 3 here, right? Okay, and now for S, which we wanna, so this is S actually, and then the map for T, which is practice here, would be, we have P, which occurred 1, we have 1 for L, and then we have A, which occurred once also, and then we have I. We have C after that, which occurred once, we have T, which occurred once, and then we have I, which occurred once, and then we have C 2 times, and then E, we have E once, right? So if we kind of do the subtraction, like maybe I'll call this, let's call this MT, and let's call this MS. So what will happen is that if we do like maybe something like MT minus MS, what will happen is we'll end up with something where we have, so this, let's see what cancels out. So we have E here, so let's just take these up. So we would say T minus the other one, so for it will become something like this here. So actually, so what we want is making T become like S, right? So we want to add some characters. So this difference here won't be enough. So let's go back a little bit and just describe what we are looking for. So what we are looking for is the minimum number of steps to make T. Maybe we would use this, but the minimum number of steps to make T an anagram of S, right? This is the unknown. What do we have available? Well, we have S and T, which are the string. From that, we can get the occurrences of characters for each. And here we need just a small definition here for the unknown, which is for the anagram, which means that just that the, so anagram of 2 strings, let's say S1 and S2, is true if S1 sorted is equal to S2 sorted, right? And also the map of occurrences, let's call it, of S1 should be the same as the map of occurrences of S2. So any of the two is enough actually to, they do the same thing essentially, okay? So what we want here is we want to make T be equal to of S, T be true. This is what we want. So I think what we can do is first sort S and then sort T and go from there. So this is something that we maybe should do. Just sort S and then maybe something like this and then sort T. And at this point, if we do that, let's see what that would be. So if I open Python here, so let's take maybe S to be this one. Oops, sorry. So let's take S to be this one and T to be this one. And let's sort S. Yeah, we can sort it that way, so maybe sorted. Okay, cool. So we have it like that, and then if we sort T2, we'll get something like that. So if we look at the differences here, you can see this one is good. We don't need to touch it. This one is good. These two are good too. And all the rest have mismatch. Right? So we have 3 mismatches here, 3 mismatches here, and then we have 3 here, 3 here. So it will give us 6 if we just do this method here. Just look at the mismatches after sorting. So what this would mean is that that's not enough, right? Unless we miss it. No, we didn't. Okay. So what can we do here? So you can see here that this mismatch, right? There is this matching here, C and this C here. So how can we account for that? What about having 2 pointers on each, right? If we find a mismatch, then move it for one of them. But the problem is, how can we determine to move for which one, right? We could do that depending on the occurrences of C here in T, right? We could just maybe have S as a map of occurrences, so that would be collections that counter. So we need counter actually here. So counter, Python counter, how do we put that? There is something that I have here in the back of my mind is possibly we will need to do some kind of a dynamic programming solution here, because this is the minimum number of steps. So kind of tells us that maybe there is a dynamic programming solution for this. Because let's say if we have 2 strings, let's say maybe, and this one here, lead. Let's say we have this string and then we have this one. Or maybe let's take a simpler one like BA, AB. And the general one is BAB and ABA. So the subproblem we are at is this. So the minimum for this will be, well, they are already an anagram, so the number here is 0, right? Now, if we introduce these two characters, which are B and A, they are different, right? But maybe there is a matching later. Like if we had an A here and then had B here, well, there will actually be already anagrams, right? So we can't tell yet, right? So just looking at one character won't be enough, right? But maybe there is another way. So, but for now, let's just look at this counter. So from collections, import counter. Then we could have counter of S. And then let's call that AC. Okay, so if we do that and maybe have the counter of T, let's call that TC. So we get that. What happens if we say TC minus SC? Okay, so we get 3, 5. So we get actually the number we are looking for, which is 5 here. What about if we do for this one? Let's say S is equal to this and T is equal to this. So if we do that, this gives us 0, which is good for this one, works. Let's try this one. Oh, do actually, so this is the first one, and then oh, sorry. Okay, TC, and then we need SC. Okay, and now we have it for each one of them. Now let's do the difference, and we get 4, right? So maybe this works actually. So let's try it. What that would mean here is what we need to do is, so if we have this diff here, let's say call this diff, how can we get the how can we get the sum of these values, right? So we can get the items, right? And then maybe let's convert them into a list. Okay. Okay, empty. Oh yeah, we need. Okay. Okay, and now if we look at the items of that, okay, now we could just, so we have for each one of them, it's key and value, right? So key, value, and what we want is to get the value, so we take the value for we don't actually care about the key, and what we can do is just take the sum of that, so we get 4. So what this would mean here is that we could just say diff equal to the counter for T minus the counter for S, and we import and then here we need to do this. Okay, let's try it. Let's submit. Maybe we will get. Oh, so that passes. Cool. There's probably another way to do this one, because if you look now, seems like that was the right way to go. Cool. Let's see how other people solve this. So yeah, so a different way we could optimize this or make it slightly easier to read is instead of doing this, we could say sum of the just give that values pretty much, because that will give us the values. One thing though is we may get negative values, right? For some, because T maybe has smaller number of occurrences, so we probably need some absolute value thing, right? So actually, no, we can just do this here. So I'll just put this here. That will mean we get a one-liner. Yeah. Okay. Okay, so that looks like a good solution. Cool.